Hi class. So today what we're going to be talking about is cake division and cake envy. All right. So how do we fairly divide a cake up? Yeah. So, we've all been there, someone's cutting their birthday cake. You're really hoping for that corner piece, all right? But instead you get a middle piece. All right. It's got no decorations on it, bland, minimal frosting. You're upset, right? You envy someone else's cake piece. Person who got the corner piece, you want their cake. All right. So turns out there's actually a really nice way to divide up a cake so that everyone feels like they got an equal share of the cake. Okay. And so we can eliminate, or at least try to eliminate, what we'll call cake envy. And all right, I understand this sounds like a kind of ridiculous, contrived problem, but just imagine the following scenario. All right, you have this beautiful island of Coucharia, it's called. All right, beautiful island. It's got some trees. All right, it's got some a nice mountain peak. Maybe some river here. Streams flowing into the ocean. All right, wow, beautiful. All right, it's got a beach. And well, turns out Coucharia has been at war with the nation of Vintown. Right? And Vintown has conquered it, okay? And now Vintown is thinking about how should Coucharia be split up amongst the states of Vintown. Now, what do I mean by that? Well, okay, there's 3 states in Vintown. Okay? And, well, all of them want different things out of Coucharia. All right. So, for instance, State 1 likes beaches. State 2, right, is looking for, they need some drinking water, right? Needs drinking water. And State 3 say they like a nice view. So now what do they need to do? They got to go up and they got to sort of partition the lands of Coucharia. Maybe this will go to 1 because they like beaches. Drinking water will go to State 2 and this one will go to 3, right? Because, each of the states want something different out of their conquered world of Coucharia. All right. And so, well, what really is this? This is the same exact thing as a cake division problem. Right? Coucharia is the cake. And we need to figure out how should we split it up so that different people get what they want and we don't have any particular person envying what anyone else has. Okay, and so maybe I've given you a more ridiculous example than splitting up cake. Maybe that made more sense, but in fact, something like this happened a lot. So back in World War II, right? Ooh, just got a little bit dark over here, right? Berlin had to be chopped up. All right, Germany lost the war, spoilers, but kind of as a consequence, Berlin was kind of split up and divvied amongst the Allied nations. And so how is it split up? Well, they had to carve it into different pieces and give each piece to one of the Allied countries. Okay? All right, so this idea of how do we chop things up into pieces that make everybody happy is exactly kind of the idea behind cake division. Okay? And so let's think about the first case where there's just 2 people. 2 parties. All right. So I bet that you actually know exactly how a cake should be split between 2 people. All right. You've probably done this method. If you have a sibling, then you've definitely done this method before. But okay, to fairly divide up a cake, we'll use the method that I'll dub you cut, I choose. Right? So say that you're sitting there and you have some sort of delicious cake in front of you. This is you. This is your little brother, all right? And you're sitting there, you're like, how do we split up this cake? Well, you say, okay, well, hold on. You get to cut it into whatever two pieces you like, and then I get to choose whichever piece I like more, right? So your little brother over here, he's got his little knife. It's like, okay, that sounds fair. What's your brother gonna do? Cuts it right in half. And so he cuts it, and you get to choose. And you get to choose, all right? Very fair, okay? So why is this process fair? The point is that the cutter cuts the pieces into what they believe to be exactly two equal parts, right? And note that the cutter and the chooser might have different preferences, but the cutter knows that they don't get to choose which piece they have. So the cutter wants to make sure that no matter what piece the chooser chooses, they'll be left with a piece that they like. Okay, so the cutter is incentivized to cut it perfectly in half. And so the cutter will be satisfied because no matter what the chooser chooses, they get what they think is half. Okay, the chooser, well, why are they going to be happy? Well, they just get first pick. And so like out of the two different pieces, the chooser can compare to see which one they like more, and they'll definitely take the one that they prefer more. Okay, so this is fair in that way. So, well, hold on. We actually have a lot of different measurements of fairness, right? And so what were those? Let's just take some time to remember. We had proportional, we have equitable, we have envy-free, we had Pareto-optimal. Now might be a good time for you to pause the video, just look back through your notes and try to think about, well, what did each of these mean? Right? Types of fairness. So proportional meant that each person gets at least 1/n of the cake, or their fair share of the cake. Equitable meant each person got an equal amount of the cake. Envy-free meant that no person would prefer to switch with another. And finally, Pareto-optimal was that there is no way to universally increase everyone's happiness. So now the question is, which of these properties are satisfied by this process of you cut, I choose? Right. Is it proportional? Is it equitable? Is it envy-free? Is it Pareto-optimal? These are the ways we want to measure fairness. So we want to see, is this going to measure up to each of these criteria? Okay. And so let's keep these questions in mind. Okay, which of these does this satisfy while we look at the next example? Okay. Okay, so we have two friends, all right, flour and frosting. Now, they buy a cake together, all right, beautiful cake, all right, nice and round, okay, and turns out that they buy a cake that's half chocolate and half strawberry. Now, the question is, how should they divide this cake up, right? They're kind of new friends, so they don't know this about each other, but flour only likes chocolate. And frosting is the opposite. She is deathly allergic to chocolate, or at least doesn't like it, okay? Now, they don't know this about each other, but they decide to play you cut, I choose. Now, before we even do that, let's just mention that there's a very easy way to split this cake up, right? One of them only likes chocolate, the other one only likes the strawberry part. So what makes the most sense is that flour should get the entire chocolate piece and frosting should get the whole strawberry piece, right? because, I mean, that's the only part of the cake they like, right? But let's see what happens when they do you cut, I choose. So let's say that flour is the cutter, frosting is the chooser. So what is flour going to do? Well, flour wants to make sure that she gets at least half the cake, right? So she needs to cut the cake in a way to make sure half of it is going to be hers no matter what. So one way that flour could cut the cake would be as follows, right? Flour could just take a knife and cut out exactly this piece here. So now half the chocolate piece is in one end, and the other half of the chocolate piece is the other end. Note that flour thinks both of these pieces are worth the same, right? Because the strawberry part just doesn't matter at all to flour. So flour cut it in a way to make sure half was chocolate, half the chocolate was in each piece. I get a lot of questions here. Okay, well, why didn't flour just kind of cut it in a different way? Why didn't flour just cut it right down the middle like this? And that's fine too, okay? Flour could cut it in either way. The point is that no matter how flour is going to cut it, okay, flour wants to make sure that she gets half the chocolate piece, okay? What could go wrong? What's a bad way to cut it? Well, okay, if flour cuts it right down the middle, then, well, what could go wrong? Well, maybe frosting takes the strawberry piece, and maybe flour gets the whole chocolate piece. And that'd be great, right? Because then everyone would have what they want. But flour doesn't know that frosting only likes strawberry. So it could go the exact opposite. And flour is worried that frosting might take the whole chocolate piece. And then flour will be left with the strawberry piece, which she hates. So even though this is the ideal scenario, all right, flour will never cut it this way. It's just too risky. So let's suppose that one of these two cuts is made on the left. Okay. Let's just use the first one. Okay. Let's go ahead with this one. Now, what will frosting take? Well, it's kind of obvious what frosting will take now, right? Frosting is like, well, hold on, you're going to give me all of the strawberry piece? Well, then I'll take it. Right? And in the end, flour is left with half of the chocolate piece, and frosting is left with all of the strawberry piece and half the chocolate piece. But note that this is still fair in some sense because, well, flour purposefully cut it this way so to ensure she got half the chocolate piece, because in her eyes, how much of the cake did she get? Well, she got half of it because the only cake that mattered to her was the chocolate. And in frosting's eyes, the entire cake, because she got the entirety of the piece that mattered to her. Okay? In fact, frosting, being deathly allergic to chocolate, is just going to throw this away, right? Frosting has no interest in that. It's not going to like it at all. Okay? And so from this example, we can see that you cut, I choose actually follows one of the fairness properties and actually doesn't follow another one of the fairness properties. So why don't you take a minute, think about that. Which one does this satisfy and does it fail? Okay, so it actually turns out that this is a proportional division. And why is that? Well, each person got at least half the cake. There are two people, so each should get at least half. It's not equitable. Right? Why is that? Well, one of them got only half of the cake, the other one got the entire cake, right? They did not get the exact same proportion. So let's skip envy now. Is this Pareto-optimal? Well, let's think about it. Did we divide the cake up so that we maximized kind of the happiness that was involved? Well, what happens? Okay, well, Flower got the chocolate half that she wanted. Frosting eats the strawberry, gets all the strawberry, that's great, but actually throws out that chocolate slice. Some of you are probably here, like, well, hold on, how come Frosting's being so horrible? Why doesn't Frosting just give this chocolate piece to Flower? Well, that's exactly what would make this Pareto-optimal, right? This is a wasted piece, so it's not Pareto-optimal, this division, right? The Pareto-optimal division would have been what we had up here, right? Where Flower gets the whole chocolate piece and Frosting gets the whole strawberry piece, right? So over here with this division, we have waste, and so it's not optimal, Pareto-optimal, right? Half the chocolate gets wasted. So for instance, right, we could make everyone happier by just giving Flower that piece that was being thrown out. So you cut, I choose is proportional, but it's not equitable, it's not Pareto-optimal, it's not even envy-free, it turns out. Okay, so it seems like a pretty good way to divide up a cake, right? But it turns out that it actually doesn't satisfy a lot of these types of fairness that we're looking for. Okay, so what I'd like to end with is an example of 3 people trying to split a cake. All right, so we have 3 people, right? A, B, C, splitting a cake. Okay, and again, the cake is exactly half chocolate, half strawberry. And what's each person's preference? Well, A and B are allergic to strawberry, while C hates chocolate. And so suppose that it's divided up this way. 2/3 of the chocolate is sliced off as one piece. 1/3 of the chocolate sliced off as the other piece. And the entire strawberry half is the third piece. This will be piece 1, piece 2, piece 3. Now further, okay, suppose that we give the pieces in this way. Okay, piece 2 will go to A, piece 1 will go to B, okay, piece 3 will go to C. All right. Now there wasn't any sort of you cut, I choose process. This is just, here's a cake, happened to be divided up this way. Now let's see, how is this cake division fair, or is it fair? Right. So how fair is this division? Okay, so the 4 things we're going to measure again are proportional, equitable, envy-free, and Pareto-optimal. And here we'll just say yes or no to each of these. And so to do this, we really need to draw out what the cake looks like to each person. Right, so to A, the entire cake just looks like the chocolate piece. Right? That whole other side just doesn't matter at all. Right? To B, the cake looks the same. The only cake that's there is the chocolate piece. Because again, A and B are allergic to strawberry. So they don't care at all about this piece. Okay, well, what about C? Well, it looks exactly the opposite to C. That C hates chocolate, so C only sees the strawberry piece. Okay. And now we want to see, okay, is this proportional, is this equitable, etc., etc. Well, we need to see how much of the cake each person thinks they have, right? So with C, C's piece, C gets the entire thing. So C gets 100% of the cake. Because again, this what we've drawn over here is the only cake to C, right? He doesn't even see the chocolate part. Right. What about B, right? B got 2/3 of the chocolate slice, right? This was B's share. So in their eyes, they actually got 2/3 of the cake. And what did A get? A got 1/3 of the chocolate piece. So A actually gets 1/3 of the cake. And so notice that if you look, right, A really only got kind of 1/6 of the whole cake, including the chocolate and strawberry part. But because of A's preference for only the chocolate piece, A actually does feel like they got 1/3 of the cake, right? Same thing with B. B only got 1/3 of the overall cake, but because of their preference for chocolate, they feel like they've actually gotten 2/3 of the entire cake. Okay? And we've seen that by drawing out what the cake looks like to each person first. And so, okay, now take a moment and try to think to yourself, is this proportional? Is this equitable, envy-free, Pareto-optimal? Okay, and so hopefully you've paused the video, thought about this for a little bit. Now let's go and try to answer maybe from easiest to hardest. Okay, I think the easiest one to see is that this is not an equitable distribution. Okay. If you look, A gets 1/3, B gets 2/3, C gets 3/3, I guess, or 100%, right? So they just don't get the same amount. So it's not equal, right? Is it envy-free? Well, it's actually not, okay? And if you look, who envies who, right? Well, if A looks at B's piece, A is going to be pretty jealous, right? B's piece is literally twice as large as A's piece. So A envies B. All right, so we already have one instance of envy, so this cannot be envy-free. Okay, is this proportional? Well, it turns out, yes, this is proportional. Why? Well, there's 3 people, so they should each get at least 1/3 of the cake. That's what it would mean to be proportional. And if you look, well, they each do get at least 1/3. A gets 1/3, B gets 2/3, and C gets 3/3, 100%. So this actually is a proportional division. And finally, is this Pareto-optimal? Again, this is always the hardest one. So is there any way that we can just make everyone happier? Right? Okay, well, I mean, we could make A happier if A took some of B's chocolate piece, right? Maybe like A and B split the chocolate just halfway down the middle, right? Then they don't envy each other anymore. That sounds great. Okay, but that doesn't make everyone happier. B's less happy, right? B is like, hold on, I had 2/3 of the cake, right? So this actually is Pareto-optimal. Right? The point is that everyone has cake that they're using and enjoying. Okay, no one has some flavor they don't like, that they'd rather trade away. Everybody has and is enjoying all the cake they have. Okay, there's no way to trade pieces to make both players happier. There's no way to give anyone more cake without taking it away from someone else. Okay. And this is really in contrast to the first example, right? Where, if you remember, frosting just had an extra piece that was being wasted and thrown away, right? So frosting could afford to just give that over the flour and make flour happier without affecting frosting's own happiness. Okay. So there we go, all right? We've seen that cake division can be tricky because different people like different things in the cake. Okay, in this case it was flavors, but you can imagine it could be, again, like side pieces, corner pieces. It could be that you like forests, rivers, beaches, right? There's so many things that different people could like, and depending on what they like, it's going to be tough to calculate whether or not divisions are proportional, equitable, envy-free, or Pareto-optimal. Okay. And so in the worksheet that we're going to be doing, I'm just going to give you some examples of divisions, and you're going to be trying to analyze them just like we did in this problem, right? To see whether or not they satisfy these four properties. And what I want to stress is that you really should try to think about what each division looks like to each person. So draw the cake out relative to each person's preferences, and then take the analysis from there. All right, thanks for listening. Good luck with the worksheet.